Okay, in part three, we're going to talk about the saturation mixing ratio. These particular lines, at least in this particular example, are the dashed green lines. And notice they go from um, lower left to upper right. And these are going to be measured in grams per kilogram. Remember we talked about humidity and we talked about different ways of measuring it. The saturation mixing ratio is one of those ways, and we're looking at how many grams of water vapor in a kilogram of air. So what we're looking at, these dashed green lines. Now you'll notice the saturation mixing ratio values in terms of grams per kilogram are not shown on this particular chart, at least the values. All we have here on the x-axis are temperature values. If I go to another chart, I can actually show you one that has the actual grams per kilogram. And what we're looking at here is a Skew T, just another version of it. And let me go ahead and get in a little bit closer down here. Notice on this particular one, besides the pressure levels, we also have the height above your head here in feet. So this is 5,000 feet above sea level, 10,000 feet, etc. But you'll notice we have the temperature lines, the isotherms, which are red in this particular case, these solid red lines. And we also have saturation mixing ratio down here in grams per kilogram. Now when we're looking at the saturation mixing ratio, we are looking at these dashed red lines here. Now, what are these dashed green lines that we see? Do you recall from part 2? These are what we call our moist adiabats. Can you identify the dry adiabats? Remember, they go from lower right to upper left. That would be these green lines. So in labs 5, 6, and 7, you're going to be working with this particular type of Skew T diagram. So just so that you're aware, if you want to color code this to help you out, the isotherms, lines of equal temperature, are the solid red lines. The dry adiabats, which is where an air parcel, a dry air parcel follows, that's these green ones, this green line that's moving from lower right to upper left. Once the air parcel becomes moist, it then follows the moist adiabat, which is the dashed green line. I'm identifying several areas of the dashed green lines. These are all the moist adiabats or pseudo-adiabat, but I like to refer to as the moist adiabat. Now the saturation mixing ratio is the dashed, looks like purple or red. It's kind of hard to tell in terms of the color, but these are the saturation mixing ratio lines, and I'll show you how we use those in just a few moments in part 4. But if I am looking at this particular saturation mixing ratio dashed line, its value is 20 grams of water vapor per kilogram of air. If I compare it to the 5, see the 5 here, and I go up to this dashed line, this particular dashed line shows an air parcel that has 5 grams per kilogram. And so 20 being greater than 5 means you have more water vapor as we go to the right. So now we have covered all of the lines on the Skew T chart. In part 4, I'm going to give you a little bit more information on how we're going to use the Skew T chart to see if a cloud will form and whether the atmosphere is stable or unstable. One quick point, if you have not viewed the video module on stability that's on Scholar, please do so before proceeding with lab number 5.